Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Key Facts, Trigonometry, Law of Cosines. Question 4, a squared is equivalent to b squared plus c squared minus 2bc, the cosine of a. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. So inbox me at memedicine@gmail.com to order this complete cram session, and definitely spread the words to your friends and classmates who also need to cram for Algebra 2. Inquire about other subject areas as well. All right, let's delve into the question. Review question 4. To measure the distance through a mountain for a proposed tunnel, surveyors choose points A and B at each end of the proposed tunnel and point C near the mountain. They determine that AC is equivalent to 3,800 meters, BC is equivalent to 2,900 meters, and the measure of angle ACB is equivalent to 110 degrees. Draw a diagram to illustrate the situation and find the length of the tunnel to the nearest meter. All right, so definitely press pause to orient yourselves and figure out the solution. Okay, I'll give you a moment to think. I already dropped a big hint right here. All right, so hopefully by now you were able to arrive at an answer, and if you weren't, that's completely fine. Let's attempt this together. All right, so the first thing we're told to do is draw a diagram, and that's what we're going to begin with. So we have our point A, the second point B that the surveyors chose for the proposed tunnel. Okay, so we have the tunnel traversing from A to B, and this represents the tunnel through the mountain region. Okay, and then we have our point C near the mountain, and then we're told that AC was determined to be 3,800 meters, and we're told that BC was determined to be 2,900 meters. Okay, and we're also told that angle ACB, well, you know, this is a big hint. If these 3 points form an angle, we can tell that a triangle is coming into fruition. So we're going to indicate our 110 degrees, and pretty much we have the makings of a triangle. So we can go ahead and fully represent that. Okay. All right. So now we have to find the length of the tunnel to the nearest meter. Well, we know 2 measures of this trio, and we also know an angle. So when we have this information, what we can go ahead and do is use the law of cosines to find the missing side. And the law of cosines states that a squared is equivalent to b squared plus c squared. You know, like the side opposite the label angle or point, we're going to make the lowercase equivalent letter, and then that's the label for the actual measured side. Okay, minus 2 BC, the cosine of A. Well, here we're going to switch A and C eventually because we don't have the measurement for A. We have the measurement for angle C, or angle ACB, which you can also call it. Okay, so let's just recap what we just did. You know, 2 sides and the included angle of what is a triangle, and we basically need the 3rd side, so we're going to use the law of cosines to find the measurement of this missing side, or in other words, the length of the tunnel, which we're asked to do right here. All right, so this is our second goal that we're attempting. Okay. All right. So now to match our diagram, it's convenient to switch A and C in the equation for our law of cosines, and also to replace capital A with this capital C. So again, what we're doing is we're going to switch A and C. That's what we did here. And then we replace this capital A or angle A with angle C, since that's our known measured angle. So the general format of our law of cosines equation as it applies to this particular scenario is going to be c squared is equivalent to b squared plus a squared minus 2bc times the cosine of c. Okay, so let's just get you oriented and a little bit more organized mentally by denoting what's what in this equation. So A is basically 2,900 meters, okay? And we're calling side A the side that opposes angle A. And B, or side B, is going to be 3,800 meters, okay? And we're calling side B, or lowercase b, the side that opposes angle B, which is denoted by an uppercase B. And the last thing that we know is the measure of angle ACB, or simply the measure of angle C, which is 110 degrees. So when you solve this, make sure your calculator, your graphing calculator, is in degree mode, or your scientific, whatever calculator you're using, okay? And if you don't know how to get to degree mode, inbox me and I'll direct you to some of my other Cram sessions that feature how to get to degree mode on a graphing calculator, specifically the TI series, but the concept should be pretty much the same on other brands as well. Okay, so what we're going to do now is plug in our known values and go ahead and solve for the length of the tunnel to the nearest meter, okay? Therefore, c squared, or the length of the tunnel squared, is equivalent to 2,900 squared plus 3,800 squared minus 2 times 2,900 times 3,800. This should be 38 and not 36. So let's just go ahead and indicate that, okay? My bad. This is an 8. Okay. Times the cosine of 110. And when you go ahead and plug that into your calculator, unless you're able to figure this out in your mind, which is excellent, you're going to get 30,388.96, and the units is meters squared, although it's not indicated here. So this is the value of c squared. We want to know the value of c, and in order to do that, we're going to have to take the square root of both sides of the equation. So when we take the square root of the left-hand side of the equation, we end up with c, and when we take the square root of the right-hand side of the equation, we end up with the square root of 30,388.96 is equivalent to 5,512.542422 meters. Okay, and our answer to the nearest meter is therefore going to be 5,500. And if you round up when you see the 5 and after the decimal place, it would be 5,513 meters. Excuse my scribble scrabble, okay? All right, so that's our answer. Hopefully you had a great time cramming through this problem. On to the next one, and don't forget to inbox me at memedicine@gmail.com to order the complete cram session. All right.